Good evening, my dear students. Welcome to Unacademy. Welcome to Kreatryx channel. And the session today is, can you solve my 10 questions in signals and systems? And I hope you are all ready. Those who are watching, please like the session, share the session first of all. Like the session, share the session before I start the questions. Good evening, Harish and Vamsi. So, let's start the questions now. The first and foremost question is from LTI systems. I am taking. Hope you are all ready. Please confirm. Please confirm whether my voice is clear or not. Please confirm whether I am audible or not. Am I audible? Am I audible? Vamsi, Harish. Am I audible? Shall I start the session? Okay. The first and foremost question, what you are going to get is like this. This is the first question. Here some information is there that slope is J. Here in this question, he has given the input to LTI system and impulse response, and he said that yt is nothing but xt convolved with ht, and the question what he is asking was, find the relationship between y of t and x of t. Is there a relationship between the output and input? He is asking. Find the relationship between output and input. Can you solve this question? The question is, he has given the input to LTI system and impulse response is also given. He is asking us to find out the output, and is there a relationship between the output and input? He is asking. Come on, try to solve this problem. Try to solve this problem. Hi, devil is always devil. Try to solve the problem. Share the session. Input is given, impulse response is given, and is asking us to calculate the output, and is asking, is there any relationship between the output and the input? Can you find out? Now, let me solve this problem. Here, we know that this is a concept of LTI system. So, let me take two papers. Come to the problem. We know that how to solve this problem. See, you also solve parallelly and I will also solve. We know that for a LTI system, if you are given an LTI system with input x of t and impulse response h of t, output is nothing but the convolution of input and impulse response. We know that output is nothing but convolution of input and impulse response. Here input is there, impulse response is also there, and you know how to perform convolution also. Now try to perform convolution, but before that we will do one thing. Let's break our h of t into two parts. So let's break our h of t into two parts. So what I am assuming is h of t is, let's say it is h1 of t plus h2 of t, where h1 of t is this one a shifted rectangular pulse like this. This is my h1 of t, I am assuming, and h2 of t. h2 of t is an impulse signal placed at 2 of strength -1/3. So both these impulse responses are ready. Now what happens to my output y of t? This is a very important problem. Answer will be, final result will be very interesting. So x of t convolved with h of t. H of t is what? I assume h of t to be h1t plus h2t. So h1t plus h2t. Using the distributive property of convolution, what it becomes? Yt is nothing but xt convolved with h1t plus xt convolved with h2t. Hope this is clear. Simply we use the distributive property of convolution. Now let's find out the first convolution and second convolution, and after that we will take the sum, then we will get the answer, no? So xt convolved with h1t, let's find out. xt convolved with h1t. How to find out? So you have xt, input xt is there, h1t, this is h1t. Now try to perform convolution. How do you are going to perform convolution? Use the normal procedure, folding, shifting and multiplying. But for that you must know what is the equation of this x of t. You must know what is the equation of this line. Use the concept of y is equal to mx plus c to find out the equation of this line. So here slope is what he said, slope is a, x of t means the dependent variable, y means the dependent variable x of t, slope is a, x means the independent variable t, plus c means it is the intercept, it is the point where this line touches the vertical axis. We will call it as y-intercept. What is that value here? B here. So the equation of x of t is at plus b. So what I want to do now, look here, my xt is at plus b, h1 of t is this rectangular pulse. Final result will be very interesting. So this is h1 of t, 4/3. Right. Now what is the normal procedure we will follow in convolution? In the first step, we will change the independent variable from t to tau. Change the independent variable from t to tau in both the input and the impulse response. So what happens in the impulse response if I change the independent variable from t to tau? This one. Because convolution is y1 of t is x of t convolved with h1 of t. You might have studied y1 of t can be written as integral -∞ to infinite x of tau h1 of t minus tau d tau. For that, the procedure what we follow is, first of all we will change the independent variable from t to tau. Second step is take the reversal of h1 of tau to get h1 of minus tau, because convolution operation is folding, shifting and multiplying. h1 of minus tau, and here 4/3 is the amplitude, it is not 1, 4/3. Let me replace this with 4/3. Right, h1 of minus tau I got. Okay, let me write here, this is 4/3. Now shift h1 of minus tau by t units, means add t to every point on the horizontal axis of this h1 of minus tau. What happens? This becomes t minus 1, add t. What happens if I add t to 0? It becomes t, and this will become 4/3. So this is my h1 of t minus tau. Now by shifting this h1 of by giving different values of t, we must find out is there any common portion between my x of tau. X of tau, how does it look like? X of tau, it looks something like this. X of tau looks something like this. Slope is now, is there any common portion between, see, while performing convolution, we will observe the common portion between x of tau and this h1 of t minus tau. So the common portion is from t minus 1 to t. So let's write y1 of t is nothing but integral. In exams, these kind of problems only you will get. T minus 1 to t is the common portion between x of tau and h1 of t minus tau. Why we are looking for common portion? Because in the operation of convolution here I am multiplying x of tau and h1 of t minus tau. So I must look for common portion, which is from t minus 1 to t. X of tau means a tau plus b. H of t minus tau value, between t minus 1 to t, which is nothing but 4 by 3. It's as simple as that, 4 by 3 d tau. Right, now try to integrate this one. If you can integrate this one, half of 75% of the job is completed. So you must be very careful. Bring the 4 by 3 outside. Now what happens if I integrate a tau? Means it become a times tau square by 2 between the limits of t minus 1 to t plus b times tau t minus 1 to t. You must be very careful. You should not commit small mistakes. There is a possibility of committing mistakes. See what will come? It is a by 2. Bring a by 2 outside. So it is t minus 1 whole square. Sorry, it's upper limit minus lower limit. No. So upper limit is t square minus lower limit is t minus 1 whole square. Right, plus b times t minus of t minus 1, upper limit minus lower limit. So what will happen if you simplify? y1 of t is equal, let's simplify, 4 by 3 a by 2. What will happen? T square a minus b whole square, a square minus 2ab plus b square plus b times t minus t plus 1. Isn't it? This t gets cancelled, t square gets cancelled. You are left with, hope you are also solving with me, y1 of t is equal to, what will come? 4 by 3 multiplied with a by 2 into 2t minus 1 plus b will come, no? Plus b. This is my y1 of t, or this is 2a by 3 2t minus 1 plus 4b by 3. This is my y1 of t. I'll call this equation as number 1. So y1 of t is completed, my dear students. So I'm able to find out now x of t convolved with h1 of t. What is left over? X of t convolved with h2 of t is very simple. Let's find out in the next slide. I'm going to the next slide. y2 of t is nothing but x of t convolved with h2 of t. But what is x of t? at plus b convolved with, what is your h2 of t? h2 of t is here, no? This one is an impulse signal. So strength is minus 1 by 3 placed at 2, minus 1 by 3 del of t minus 2. Okay, fine. Minus 1 by 3 del of t minus 2. Fine. Now what will happen? Convolution of a signal with a shifted impulse. Shifted signal, no? Shifted signal. So what I'll getting? I'll be getting minus a by 3 convolution of a signal with a shifted impulse. Simply the signal will be shifted. So wherever you have t, replace it with t minus 2 plus b. Isn't it? Plus b by 3 here. Right. Now y2 of t also I got. So overall your y of t, what it will become? This y1 of t y2 of t. Let's add y1 of t and y2 of t. We are having both, no? What is y1 of t? 2a by 3 into 2t minus 1, 2a by 3, 2t minus 1 plus 4b by 3 plus 4b by 3. Now what will happen here? Minus is there, no? Here when this minus goes inside, this becomes minus. Minus a by 3 into t minus 2 minus b by 3. What is that you are going to get? Your y of t will become 4a t by 3 minus 2a by 3 plus 4b by 3 minus at by 3 plus 2a by 3 minus b by 3. 2a by 3 minus 2a by 3 gets cancelled. So 2a by 4at by 3 minus at by 3. So your y of t will be 3at by 3, 4b by 3 minus b by 3, b by 3. Sorry, 3b by 3. Or what is that? Your y of t is nothing but at plus b. At plus b is what? X of t only. So your y of t is x of t. This is the relationship between y of t and x of t. Hope you enjoyed this problem. Please reply. Y of t is simply x of t only. These kind of problems you must solve. Reply Harish, Vamsi. Shall I move to the next problem? Shall I move to the next problem? Please reply. Shall I move to the next problem? Okay. The relationship between y of t and x of t is y of t is equal to x of t. If you are unable to understand after the class, you go to the problem once. Very interesting problem. Now come on, try to solve this one. The value of the continuous time Fourier transform at omega is equal to 1 is how much? Where x of t, where x of t is equal to this signal is given. He is asking us to calculate the value of the Fourier transform at omega is equal to 1. Let me tell you, see the questions what we are doing, lot of concepts will come. You will be going with lot of good questions, that is guaranteed within 15 to 20 minutes. The value of the continuous time Fourier transform at the point omega is equal to 1 he is asking, where the signal is this one. So he is asking us to find out the Fourier transform of this signal, and in the Fourier transform, what is the value of the Fourier transform at omega is equal to 1? Come on, try to answer this one, my dear students. Like the session, share the session. Any answers? Any answer? He's asking us to calculate the value of the continuous time Fourier transform at omega is equal to 1, where he has given one signal xt. Okay, I'll do one thing. I'll start solving this problem. If you are getting any answer, type your answer in the live chat, no issues. Okay, now observe here. For solving this problem, you need one property of Fourier transform, which is nothing but the frequency convolution or multiplication property, which says that if the signal x1t forms a Fourier transform x1 of omega, x2 of t forms a Fourier transform pair with x2 of omega, then x1 of t multiplied with x2 of t forms a Fourier transform pair with 1 by 2 pi x1 of omega convolved with x2 of omega. Make use of multiplication in time domain is equivalent to convolution frequency domain. Now how you are going to utilize this property? Observe here. Now what is the signal given? Xt is equal to sin t into sin t by pi t square. Now can I write this signal as sin t by pi t multiplied with sin t by 2 by t? Can I write like this? Yes, I can write. Now what I'll do is I'll put one pi here, I divide so that I'll multiply with pi. Right. Now if you observe this signal sin t by pi t and sin t by 2 by pi t, they are multiplied in time domain, means in frequency domain they are convolved, right? So first of all, let me one important Fourier transform pair, which is nothing but sin 80 by pi t. Sin 80 by pi t in time domain forms a continuous time Fourier transform pair with rectangular pulse varying from minus a to a in frequency domain. Try to remember this one. Try to remember this one. Without knowing this Fourier transform pair, don't go to exam, because definitely this concept will be involved. So if you're not thorough with this one, learn this Fourier transform pair, how it came and what is duality property of Fourier transform. Learn this concept and go. Now look here, utilizing this one, sin t by pi t, look here, sin, what is the continuous time Fourier transform? Rectangular pulse varying from what? Minus 1 to 1, because a value, a is equal to 1 by 2, what will happen? Sin t by 2 by pi t, which forms a Fourier transform pair with rectangular pulse varying from minus 1 by 2 to 1 by 2. Now do one thing here, if you observe in time domain multiplication is done. So in frequency domain what you have to do? Convolution you have to do from the prop. So what will happen here? Pi is also there, no? Here pi is also there, we include that pi also, but before that, what is the convolution of two rectangular pulses of unequal widths? Of two rectangular pulses of unequal widths is nothing but a trapezoidal pulse. Nothing but a trapezoidal pulse. So trapezoidal pulse will look like this. What is the range of output? We know that range of output is from sum of lower limits to sum of upper limits. So it will be minus 3 by 2 to 3 by 2. Now if you want to know this width, okay, if you want to know this width is nothing but width of smaller rectangular pulse. Means here what is the width of this rectangular pulse? 1. What is the width of the first rectangular pulse? 2. So remember, this width is nothing but width of smaller rectangular pulse, means this 1. 1 means what could be this point? Minus 1 by 2. With symmetry this is 1 by 2. Now if I want to know the slope of this one, slope of this line, simply multiply the amplitudes. If I want to know the slope of this line, simply multiply this amplitude with this amplitude. Slope is 1. Here if I want to know the slope, multiply the amplitude with the negative sign. Now I know this slope. Observe here, I know this slope. I know this point. Can I calculate this point? Can I calculate this point? Can anybody tell me what is this? What could be this point? Can anybody tell me what is this point? See here slope is 1, here this will be half of that, with slope 1 it is decreasing now, so it will be 1 by 4. So what is the answer? 1 by 4. Answer is 1 by 4. Shall we go to the next problem? Yes, this is a problem. Here a network is given and he said if x of t is equal to cos t, find y of t. If x of t is equal to cos t, find y of t, he said. If x, find y of t. How to solve this problem? Take 1 minute time. Try to solve this problem. Okay, observe here. How to solve this one? See, you might have studied one concept in your LTI systems or Fourier transform, that if you are having an LTI system, with frequency response h of omega, and if you are going to give a cos omega 1 t as the input, your output will be of the form a1 cos omega 1 t plus phi. Magnitude and phase will change, frequency will not change. The changed magnitude is nothing but magnitude of h of omega at omega is equal to the input frequency omega 1, and the changed phase phi is nothing but phase of h of omega, at the input frequency omega 1, right? Now the question is, can I get the frequency response from this network? If I can get the frequency response, yes, I can use this property, right? Now how to get the frequency response? First of all, can you frame in a differential equation between input and output? Here if you observe, x of t is the current coming like this, y of t is flowing through the inductor. Now can you tell me what is the current flowing through the resistor? The difference, x of t minus y of t will flow to the resistor, and we know that this inductor and this resistor, they are in parallel. Parallel means voltages are same, no? So what is the voltage offered by a inductor? L di by dt, means L means 1 Henry, dy of t by dt must be equal to voltage offered in a resistor. IR, current is x of t minus y of t multiplied with 1, resistance is 1, or dy of t by dt plus y of t is equal to x of t. I got a differential equation, and remember this differential equation represents a LTI system, linear time invariant system, right? And I hope that you know how to find out the linearity and time invariance of a differential equation. Now can I get the frequency response? Yes, applying Fourier transform on both sides, j omega into y of omega plus y of omega is equal to x of omega, or if you take the ratio of y of omega by x of omega, I will get the frequency response h of omega, which is nothing but 1 by 1 plus j omega. Now I got the frequency response. Now I can use the concept, no? I got the frequency response 1 by 1 plus j omega. So observe here, h of omega is, very good questions are coming, be patient. Now what is the input we are going to give? Cos t, he said, no, xt is equal to cos t, he said. So output will be of the form a cos t plus some phi, where a is equal to magnitude of h of omega at omega is equal to input frequency 1 radians per second, magnitude of 1 by 1 plus j omega at omega is equal to 1, or this is 1 by under root 1 upon root 2. The changed phase phi is nothing but phase of h of omega at omega is equal to 1, or phase of 1 by 1 plus j omega at omega is equal to 1 minus tan inverse of omega minus pi by 4. So your y of t will become 1 by root 2 cos of t minus pi by 4. This will be your answer. First of all, write the differential equation, get the frequency response and calculate the output. Hope you enjoyed this problem. So I am switching to the next problem, this one. I am going to take a problem from Laplace transform, and he said consider the LTI system for which the following information is given. See here what he said, x of s is s plus 2 by s minus 2 and x of t is 0 for t greater than 0. He gave some information about the input Laplace transform he gave, and output signal also he gave, y of t also he gave. And what is asking, determine the output if the input is x of t is equal to e power 3t, where t varies from minus infinite to plus infinite, he said. Come on, how to solve this problem? How to solve this problem? Now my question is, first of all, can anybody tell me first of all what is the idea? Can you tell me any idea to solve this problem? Can anybody reply in the live chat how to solve this problem? How to solve this problem? Any idea? Any idea how to solve this problem? Okay. The next question is, can you find out the Laplace transform of e power 3t? Can you find out the Laplace transform of e power 3t? No, we cannot find out the Laplace transform of e power 3t. Find transfer function, then output for the given input. Yes, Ramesh Kumar, you are nearer. You are nearer, Ramesh Kumar. But here, for that can I find, see Ramesh Kumar, what you are saying is right, but can you find out the Laplace transform of e power 3t? E power 3t Laplace transform, can you find out? We cannot find out the Laplace transform of e power 3t. For these kind of everlasting signals, everlasting means exist from minus infinite to plus infinite, we cannot find out the Laplace transform. In particular, bilateral Laplace transform I am saying. Suppose if I ask you what is the bilateral Laplace transform of 1? 1 means it can be written as u of t plus u of minus t. See, linear combination means you must have common ROC, then only you can find out the Laplace transform. U of t sigma greater than 0, u of minus t sigma less than 0. So there is no common ROC, you cannot find out the Laplace transform of 1 or this everlasting signal e power 3t, in which case what you have to do? See, we cannot find out the Laplace transform of e power 3t, but given these kind of signals as input to LTI system, we can find out the output using Eigenfunction property. Yes, Eigenfunction property. See, whenever you are having these kind of everlasting signals, go for Eigenfunction property of Laplace. What it is saying? If input to a LTI system is a signal of the form e power st or e power s naught t, then output is the same e power s naught t multiplied with h of s naught. This is the Eigenfunction property. If input to LTI system is a signal of the form e power s naught t, output is the same e power s naught t multiplied with h of s naught. So, in our particular problem, what is the input he gave? E power 3t. Yt is the same e power 3t multiplied with h of 3. Oh, half of the job is done. If I can find out h of 3, I'm going to get my output. But how to get h of 3? H of t is nothing but transfer function at s is equal to 3. How to find out transfer function? Transfer function is nothing but the ratio of Laplace transform of output to the Laplace transform of input, considering the initial conditions to be 0, right? X of s is anyway there with you. Now y of t is given, you calculate y of s and take the ratio, you will get h of s. In that h of s, substitute s is equal to 3, you will get h of 3, substitute here, you will get the answer. Come on, tell me. So let me add one paper. Look here, what is x of s? X of s is s plus 2 by s minus 2, fine. And y of t, what he gave? I can write my y of t as 2 by 3 minus e power 2t u of minus t plus 1 by 3 e power minus t u of t. Oh. If I calculate the Laplace transform, 2 by 3, what is the Laplace transform for minus e power 2t u of minus t? This is 1 by s minus 2 with ROC sigma less than 2 plus 1 by 3 1 by s plus 1 with ROC sigma greater than minus 1. Now you have y of s, you have x of s. H of s you calculate, which is nothing but the ratio of y of s to x of s. And if you calculate, see whether you are going to get this one or not. S by s plus 2 see whether you are going to get this one or not, h of s. Please reply. To take the ratio, check whether you are going to get this one or not, h of s. H of 3 will be 3 by 20, or your y of t is what? E power 3t this is your output. Problem, important model as well. Whenever you are given everlasting signals as input, go for Eigenfunction property, because we cannot find out the Laplace transform for those signals. Hope this is clear. Shall I go to the next problem? Yes, let's go to the next problem. Fine. Look at the next problem is like this. Determine which, if any, of the real signals, these are all real signals, depicted have Fourier transform that satisfy the condition real part of x of omega is equal to 0. Now he has given different signals. So first one is A, here, second one is B, third one is C, fourth one is D, fifth one is E, sixth one is F. Now these are all real signals. Now he is asking how many of these real signals satisfy this condition, real part of x of omega is equal to 0. Come on, type your answers. I will be waiting for your answer. I will be waiting for your answer. How many of the signals there satisfy, all are real signals, satisfy this property, real part of x of omega is equal to 0. A, B, C, D, E, F. What could Jaitirtha has said A and D. A and D. Jaitirtha, any more answers? Now look here, I will tell you a concept. First of all, understand the concept, observe here. So this is a real part of x of omega, B and doubt, but A and D pakka, this is imaginary part of x of omega. Now observe here. Now I see this real signal Fourier transform as real part of x of omega, imaginary part of x of omega, and always remember real part of x of omega for any real signal is always even function. Even function. A by a square plus omega square is even function, whereas imaginary part will be odd function. Remember, real part, you take any real signal, calculate the Fourier transform, the real part of that Fourier transform will be even, whereas imaginary part will be odd. Now what he said, real part of x of omega is 0. So real part of x of omega is 0 means in the Fourier transform we are having only imaginary part which is odd. In the Fourier transform we are having only imaginary part, means that must, and which is odd, means what? See, we have many relations like this. Look here, if the signal is real and even, signal, while discussing Fourier transform we will discuss this topic. If the signal is real and even, Fourier transform is real and even. If the signal is real and odd, Fourier transform will be purely imaginary and odd. If the signal is real and even, Fourier transform will be real and even. If the signal is real and odd, Fourier transform is purely imaginary and odd. Now our Fourier transform is imaginary and odd, means in time domain the signal must be real and odd. The signal must be real and it must be odd. Now as per the condition what he gave, real part of x of omega is 0, he said, means imaginary part we are having, and it will be odd definitely for a real signal. So Fourier transform is imaginary and odd, means the time domain signal must be real and odd. So from the given A, B, C, D, E, F, you identify which are real and odd, which signals are real and odd, and we know that odd signal must pass through 0. So first one, if you observe A, it is an odd signal, first one satisfied. Second one, by looking at this one, no, this is not a odd signal. Second, third one, not a odd signal. Fourth one, yes, it is a odd signal. Fifth one, even signal. Sixth one also even signal. So the option correct answer is A and D. What Jaitirtha and Aravind Reddy has said is correct answer, A and D. A and D. A and D. Similar kind of problem, similar kind of problem I am going to give one more. Observe here, same problem, A, B, C, D, E, F. Now determine which, if any, of the real signals depicted in the figure have Fourier transform that satisfy imaginary part of x of omega is equal to 0. Come on, try to solve this one. Imaginary part of x of omega is equal to 0. Any more answers? Only 2 persons are giving, Jaitirtha and Arvind Reddy. What about others? EF. Kashish Kumari, BCEF. Okay, let's observe the problem. See, imaginary part of x of omega is 0. Look here. Imaginary part of x of omega is 0 means only real part we are having. Real part of x of omega we are having. Imaginary part of x of omega is 0 means what? Imaginary part of x of omega, imaginary part of x of omega is 0 means real part of x of omega we are having, and real part is anyway even. For real signal, real part of Fourier transform is always even. So real and even, Fourier transform real and even means signal is also real and even. Signal is also real and even. Let's observe. First one is not even, second one is not even, third one is not even, fourth one is not even, fifth one even and real. So this is the answer. EF. Shall we go to the next problem? Please give your reply. B, C. B, C are neither even nor odd. Please give reply so that I can move forward. Same problem. Yes, exactly. B, C are neither even nor odd. Come on. Same question in different way. This is A, this is B, this is C, this is D, this is E, this is F. Now the question is, determine which, if any, of the real signals depicted have Fourier transform that satisfy integral minus infinite x of omega d omega is 0. Try to answer this one. How many of these real signals satisfy that property? Integral minus infinite x of omega d omega is 0. Sir, figure కనిపించట్లేదు 0 దగ్గర. Where 0 man? Okay. Equations you are not concerned, Arvind. E power minus t square by 2 Gaussian pulse. This is t square e power minus mod t. Come on, type your answers. How many of these signals satisfy that relation? ADF area property. Okay. Any more answers? Any more answers? AD. I think Arvind, your favorite is AD. ADF, this is area property. Now look here, let me reveal the answer. Let me reveal the answer. B and C also, sir. Let me reveal the answer. Here, what is it and what is the area property? First of all, what is your Fourier transform expression? This is the Fourier transform expression. Inverse Fourier transform expression. What happens if I substitute omega is equal to 0 here? What happens if I substitute t is equal to 0 here? From this, we say that if you want area in time domain, observe the Fourier transform at omega is equal to 0, will say from this. Area in time domain is nothing but value at omega is equal to 0 in frequency domain, will say. From this, what will say? Area in frequency domain is value at t is equal to 0 in time domain multiplied by 2 pi, will say. In F domain, we won't get the 2 pi also. So what is it? Look here. Integral minus infinite to infinite x of omega d omega. Area and frequency domain is 0. Means corresponding x of 0 must be 0. The signal, see, if I apply the area property, signal at 0 must be 0, no? At the instant 0 must be 0. Then only the area will be 0. Right? Observe here. Now we'll see which of the signals satisfy this property. Means we came to a conclusion that if the value of this signal at an instant 0 is 0, area will be 0. Or sorry, Fourier transform will be 0. Sorry, the area under the Fourier transform will be 0 if the value of the signal at the instant 0 must be 0. Now first one, yes, the value of this at 0 is 0. First one is satisfied. Second one, at 0 the signal value is 0. Yes, this is also satisfied. This is also answered. Third one, yes, at the instant 0 the signal value is 0. This is satisfied. Fourth one, yes, at the instant 0 signal value is 0. This is also satisfied. Fifth one, at instant 0 it is not 0. And the sixth one, yes, at the instant 0 it is 0. So the answer is A, B, C, D, F. Except E. Yes, except E. Convinced? Convinced? B, C also correct. Yes, yes, yes. Now, the next problem. This one. Determine which, if any of the real signals depicted have a Fourier transform that satisfy this condition. Now, this condition must be satisfied. Integral minus infinite to infinite omega into x of omega d omega is 0. Come on, tell me how many will satisfy. Hope everybody is enjoying the questions. how many of these signals will satisfy this condition? Area under omega into x of omega d omega must be 0. What is the condition? Area under omega into x of omega. Observe here. See, area under x of omega d omega is equal to 0 means what? Area under x of omega d omega is equal to 0 means what we got? X of 0 must be equal to 0. See, area under x of omega d omega is equal to 0 means this condition we got. See, the inverse Fourier transform of the signal at 0 must be 0. If you compare with the previous one, integral minus infinite x of omega d omega is 0 means what is the condition we got? X of 0 is equal to 0 means I have x of omega, so its inverse Fourier transform at t is equal to 0 must be 0. Now applying the same, what is the inverse Fourier transform of omega into x of omega? Can you tell me? Can you tell me what is the inverse Fourier transform of omega into x of omega? Use your differentiation in time property. D by dt of exactly d by dt of x of t. What is the Fourier transform? J omega into x of omega, right? If I bring this j here, minus j into d by dt of x of t forms a Fourier transform pair with omega into x of omega. So here from this, minus j times d by dt of x of t must be 0, or simply d by dt of x of t, at t is equal to 0 must be 0. This is a condition. Look here, in the previous one what we got? Integral minus infinite x of omega d omega means x of omega is there, so its inverse Fourier transform at the instant 0 must be 0. Now in the place of x of omega, I have omega into x of omega, so its inverse Fourier transform, that is minus j into d by dt of x of t at instant t is equal to 0 must be 0. So now how you are going to identify? If you find out the inverse Fourier, differentiate and substitute t is equal to 0, the signal must be, the value must be 0. Now look here, what happens? This is an odd signal. First one is an odd signal. What happens if I differentiate this one? I'll get an even signal. Even signal, its value at 0 cannot be 0. Even signal value at 0 cannot be 0. So this cannot be the answer. Now second one, B. So here if I differentiate this impulse, look here, listen carefully. If I differentiate this impulse, I'll get a doublet function, because differentiation of impulse signal is doublet function. At 1 I'll get, but at 0 it is 0 only. If I differentiate the second signal at the instant 0, I'll get the doublet function at 1, but at the instant 0 the value of the signal will be 0 only. So second one is satisfied. Third one, if I differentiate the third signal, I'll get some signal here which is 0 at 0. This is also satisfied. And the fourth one is an odd signal. If I differentiate this one, I'll get an even signal whose value at 0 cannot be 0. So this cannot be the answer. Now E, this is an even signal. Even signal means if I differentiate, odd signal will come. Odd signal must always pass through 0. That is the compulsory. So this is satisfied. And last one, this is an even signal. Last one is also even signal. Differentiation of even signal is odd signal. Yes, definitely it will pass through 0. So your answers will be, possible answers are B, C, E, F. B, C, E, F. If you differentiate the signal and if you observe at t is equal to 0, the signal must be 0. For B it is satisfied, for C it is satisfied, for E it is satisfied, for F it also it is satisfied. A and D not satisfied because they are odd signal. Odd signal is even signal. Even signal value at the instant 0 cannot be 0. Hope you are done with this. And the last one, same question but in a different context. I am asking. This is A, this is B, this is C, this is D, this is E, this is U. Determine which, if any, of the real signal depicted have Fourier transform that satisfy the condition x of omega is periodic. X of omega is periodic, he said. X of omega is periodic. X of omega is periodic. See, if x of omega is periodic, what could be the time domain signal among this A, B, C, D, E, F? Jaitirtha has said that A and C, okay. And that is also a doubt. Pratyush, A only. Yes, Pratyush, you are absolutely right, man. Always remember, my dear students, if x of omega is periodic, means time domain signal also is also periodic. If x of omega is periodic, means what does this mean? This means that x of t is also periodic. X of t is also periodic. What are the examples you can give? Impulse train, if you take impulse train in time domain. Impulse train in time domain. So impulse train in time domain is a periodic signal whose Fourier transform is also impulse train in frequency domain. In frequency domain also it is impulse train only. So in frequency domain we have periodic nature, means in time domain also it must be reflected. In time domain also it must be reflected. Suppose if I take pulse train like this. Pulse train if I take like this. What is the Fourier transform of pulse train? Anyways, here this is not periodic. Let's not discuss about this pulse train. Pulse train Fourier transform is not periodic. Let's not discuss here. This is periodic, means definitely in time domain the signal must be periodic. So among the options, this is periodic. If you calculate the Fourier transform for this one, definitely here this x of omega is periodic. X of omega is periodic means x of t is also periodic. So A will satisfy, B no, C no, D no. You have to look for a periodic signal. Option A is only the answer. Only A. Yes, Jaitir, you are right. So these are the questions which I wanted to discuss with you, and hope you enjoyed this question, and give your comments regarding the questions. And my dear students, if you want to take admission in Unacademy, we have 2 subscriptions, the Plus subscription and the Iconic subscription. In the Plus subscription, we have live classes, crash courses, weekly tests, doubt solving sessions, batches in English and Hindi, rank improvement batches. Iconic, personal coach is given, study planner, study booster sessions are there, personal test analysis, doubt clarifying instructors are there, preparatory study material also given to the students. And coming to the fee structure, this is a fee structure. If you are planning to take Plus subscription, for 1 year 27,225, for 1.5 year it is 34,650, and for 2 years 39,600. And Iconic, for 1 year 45,225 and 2 years 66,600. And we have Unacademy Combat on the coming Sunday, that is on 27th at 11 a.m. Don't miss. And if you have mechanical friends, civil friends, inform them, and computer science friends also inform them. The advantage is if your rank is between 1 to 3, you will be getting 100% discount on plus subscription. 4 to 10, 75% off. 11 to 50, 50% off on plus subscription you are going to get, and 51 to 100, 25% off on plus subscription you are going to get. And these are the currently running batches for ECE. For 2022 aspirants, we have Laksha batch, and for 2023 aspirants, we have Arohan batch. And these batches have just started on 23rd of June. And if you want to take admission subscription, use the code KVS Live. And for electrical students, Laksha batch for GATE 2022 and Arohan batch for GATE 2023, and started on 23rd of June, you can take subscription. So using the code KVS Live. And there is a chance of price hike in the subscriptions from July 1st. Let me tell you, from July 1st, the prices are going to increase, and try to take the subscription as soon as possible to beat the price hike. And you have one more feature coming in the Unacademy app, which is nothing but efficient revision via digital notes. So if you take the subscription, you will have all these advantages. And these are our channels, my dear students. And you can follow me on Unacademy, unacademy.com at KV Swamy. And finally, thank you. Like the session. Don't forget to like the session. Share the session. Don't forget to share the session. If you are not subscribed yet, subscribe the channel and press the bell icon so that you get regular notifications. Okay, tomorrow morning we are having our regular class at 7:30 a.m. on the Kreatryx channel in Impulse batch. Thank you, my dear students. Take care, stay safe, stay healthy, and happy learning. Thank you.